Alrighty, let me see here. Let me show this. We're going to start today with a video. We're going to start today with creature borking. We're going to start by looking at a video first. So there are a couple of ways that we can talk about pH that we talked about last time. And it's kind of a... Here, I'm just going to start this video.
Here we have 6 speakers.
Oh, gosh. Where we can use electronics to determine the pH of something. Or, if we want to do it a little bit more old school, we can use something called an indicator. Far, far cheaper. Indicators are compounds that change colors at certain pHs. And this particular video has a mixture of indicators, which together form something called the universal indicator. And we're going to see that if I add, to this first one I'm adding 1 drop of acid, we're going to see that's going to turn it a particular color, a yellowish color. I'm going to add 2 drops of acid to this. Now I have a kind of orangey. And then the rest of the acid. Why not throw the whole thing in there? And we get it red. So we can see that even just small, just drops of concentrated acids, this is hydrochloric acid. Right now I'm adding sodium hydroxide now as a base. These small volumes are enough to change the pH of these solutions really drastically. And so we'll see here, this one will be nice and purple for us. And so, ta-da, we have made a nice little rainbow here. And we're going to see that indicators like this are very useful because if we're looking for a reaction to happen at a certain pH, this is a great way to do it. We're going to see that when we talk about titrations, it's the same way. Just while I'm here, though, since I have this open,
So here we
we have the same universal indicator, but this time we've added something special to it called a buffer. And we'll talk about what a buffer is in a little bit. But first, let's just watch what happens when we add the same stuff to these beakers now, with the buffer inside. Same order and everything. So that's the drop of acid. Couple drops, ton of drops. Where's the base? Here it comes. Alright, and then we see a ton of base, and notice that nothing happens. So, despite adding all that kind of same amount of acid and base that we added last time, nothing happened. So we'll talk about what buffers are, and just for fun, let's dump the whole thing in there, and we see again it's still that greenish color. So we've done something special there to prevent this from changing pH very much. Alrighty, let me open up the tablet now. So today's going to be our last lecture pretty much. Let's see here. Oh, I see. I just need to turn that off. There we go. Because we're pretty much done. We have just a few little kind of topics here there to talk about. You guys already did a Titration Lab, so it's essentially just stoichiometry about solutions. So, you're adding X milliliters of something, acid or base, to a known volume of another one, and you're able to see kind of what their molarities might be. And so that you've kind of dealt with in the lab. But it's just a way of quantifying things, again, not using electronics. Nowadays, it's a lot easier if you want to just plug in a pH meter, throw it in your solution, and you get a voltage out, which it converts to a pH. Apparently I have a chorus of dogs today, so Creature is going to be singing for us as well as barking, so go figure. So, well, I mean, I guess you can just kind of write it out. Titrations are where you add a oh no, that is right. Add a precisely measured volume of liquid of unknown concentration to an exact volume of known concentration. So this would be something like where you would have sodium hydroxide, typically is something that you know. You might have a mystery acid, let's say it's, I don't know, what acid shall we use? I don't know, nitric acid. Standard double displacement reaction rate, we get water and sodium nitrate. For a titration, you might say, okay, I have exactly 20 mLs of this, and I know that again, you can know either one. Typically, you're standardizing things with the base, but it doesn't have to be that way. And let's say that this was 0.125 molar. And we can even put an extra 0 there. With the NaOH, we might say, okay, well, we have an unknown concentration of that. But we know that it took, let's say, 22.64 milliliters to do the titration. How that works is you have a piece of equipment called a burette. And burettes have very, very, very fine graduations on them, so you can see exactly what the volume is inside there. And you're allowed to kind of, this is a stopcock or a valve that you can open to allow it to drip, and you can do it drop by drop. And so you can get this to move very slowly, so you'll be able to add exactly as much as you want. You'll have your known thing in there, in a beaker or a flask down there, and you'll typically have an indicator as well. Remember, those are those compounds. Let me learn how to spell real quick. Indicator. There we go. Often something called phenolphthalein. Phenolphthalein is a very commonly used indicator. It goes from colorless to pink, to bright pink, at around pH of 8 or so. So if you have an acidic solution down there in your beaker, it's going to be colorless. And then you can add drops of base. You can drop the base, into this solution until it turns very, very slightly pink. At that point, you will have finished your titration. You can read your burette, see exactly how much you used of your solution, and that would give you some typically random number like this, where say now I've used 22.64 mLs of this NaOH solution. And once doing so, then you can figure out the molarity of your base solution, or your acid solution, whichever one you don't know. And so, how that calculation looks, this is just solution stoichiometry, as always, if you want to plan it out. Obviously, I can't give you too many problems like this because these take a bit of time, right? So, if we want to plan this out, we know about nitric acid. We're looking for NaOH, so we should definitely have that in our unit plan somewhere. We have Gumbo shrieking too. He's just wandering around the hallway just shrieking. They know the end of the semester is here, and they're like, I'm done being silent for class, right? This is our reaction coefficients here, and this is our molarity. And remember, in order to find the molarity of NaOH, that'll just be the moles of NaOH over the liters of NaOH. And so whatever answer we get out from this unit conversion will plop into that formula there. So we have 0.02 liters of nitric acid. And its molarity was, so again, I've just converted to liters. Hopefully that's not problematic. This is just the same thing that we've done last chapter. We have our 1 mole nitric acid for 1 mole of NaOH. Do this. Where's my calculator? Oh, it's over there. One sec. Calculator. Okay. 0.02 times 0.125 is 0.0025 moles of NaOH. If we want to do the molarity, it's going to be that moles over our liters, which was 0.02264 liters. 0.02264, and we get 0.1104 molar. And we've done it. We've standardized our base solution, as it were, or figured out the concentration of base in that solution. Typically, titrations are either done with redox chemistry or with acid-base chemistry. Acid-base being a little bit more common than redox, but they are both possible. Titration is just another, it's a way of figuring out that volume of the unknown solution. That's the only thing. It's just using this burette, this special piece of equipment that's going to tell you exactly how much liquid that you put in, so you can measure that accurately as you go. Because you want to just keep adding until it fully reacts, right? Once all your acid has reacted, there's no more acid, it's pH 7. You add 1 drop of base, it's going to be like pH 10 or 11. It'll definitely turn your thing pink. So you'll know exactly when you've added enough of your solution to react completely. And acid-base reactions also usually go to 100%. They don't usually have low yields, so their reaction yields are often quite high. All right, but again, same old idea from last time, and you've done your lab sim on this anyway, so we're good there. Alrighty. The last thing to talk about, the last thing of the whole class, is buffers. So buffers are going to be solutions of a weak acid and its conjugate base. For example, if we take a solution of acetic acid and sodium acetate, we know that weak acids don't break up fully. They break up in fact, just a little bit. And because they're weak acids, they will have weak conjugate bases. Weak conjugate bases are also only going to form hydroxide to a small extent. So these two don't. We're going to see how they're going to work. So we have acetic acid here. Of course, that'll be our acid. This will be our conjugate base. And how these work is they're going to be solutions that will prevent pH from changing drastically. We're going to see that these two work together to prevent significant pH change. The reason being, if you have the solution, we know acetic acid is mildly acidic, sodium acetate is mildly basic, acetate being the conjugate base. If we were to go ahead and add some strong acid to this, we're going to see that it's going to react with our sodium acetate to produce the acetic acid out again. And so what's going to happen here is we'll have our just standard acid-base reaction, where we'll have our proton moving from one thing to another. We now have generated more. We had a strong acid here. Strong acids can affect pH very effectively. But now we've turned it into a weak acid, which is not going to be able to do a large pH change. And if we were to try it again with a base, we're going to see that the acid component of our buffer will be able to balance that out. So we have now a strong base that we're putting in, and what we get out is a weak base. So these components of our buffer, the acetate and acetic acid, are able to kind of minimize any kind of damage that would be done by strong acids or strong bases. Because we're going to see that if you try and add a strong base to it or a strong acid, they'll just react away, forming more of themselves. And because they're weak, they're not going to have a huge effect on our pH. And we saw that in the video that if we had those buffer solutions, we added a whole bunch of acid to them, they're not going to change within reason. So it just depends how much concentration you have of your buffer components there. But you're going to see that you can make a buffer out of any kind of acid and conjugate base pair that you like. Our bodies use many different buffer systems. We have proteins as buffers. Many proteins act as buffers. Albumin. We have the bicarbonate buffer system, which goes between carbonic acid and bicarbonate, and even carbonate. And we also have the phosphate buffer system. So dihydrogen phosphate and hydrogen phosphate can work as buffers too, as a conjugate acid-base pair. Essentially, what you need to know about buffers is that they resist pH change and that they are made of an acid and their conjugate base. Gumbo, come here. Come here, Gumbo. You don't have to be screaming all the time. Come say hi to everyone. There you go. Gumbo is Oz's son. Gumbo is always on the lookout for food. He probably is still hungry after breakfast, but he's on a diet. So you can kind of have a look at what those are. Buffers usually will maintain your pH within 1 pH unit. So obviously for a living system, that's not really good enough. So that's why we have many buffer systems in place, is that they'll all be able to kind of keep it in a kind of close range there. All right, so that's it for buffers. So that's just what we need to know. So I'll just write it down one more time. So buffers, they resist pH change. Gumbo, relax, mister. And they are made of a weak acid plus a conjugate base. Now, it only works if you use the weak acid and its conjugate base. So you can't say, I'm going to take acetic acid and put in potassium oxalate or something. Because oxalate is the conjugate base of a different acid. Obviously of oxalic acid, right? So you're going to want to only make sure that it's paired things. So you can't have a weak acid and a generic weak base. It has to be the pairs. Because you're going to see there, what we do is we remake each other. So the sodium acetate here is the same thing as the acetate. And of course, we get our acetic acid there too. So it's important that you regenerate your own things while these things are reacting. And you'll learn more about this in 113 if you take that class, because we talk about equilibrium and how weak acids actually work. So, alrighty. That's it for acids and bases. That's it for introduction to chemistry, in fact. So, let me just take a quick peek, real quick, to see how many questions we have so far for our review. Okay. So we have basically 1 day's worth of questions so far. If the amount of questions is going to be the same, what we'll do is we'll have this review then on, let's have it on Wednesday. So if you put more questions up, if as you're going through your old exams, as you're going through the acid-base practice thing, if things are still coming up where you have questions on them, I'm happy to go over those. So we'll have a review on Wednesday. If there are still more questions or I don't get to all of them, then we'll continue and do it again on Thursday. So we have the option to just do more of it. So for right now, tomorrow you're going to want to study. Wednesday will be our review day. If you want post questions, we have a lot already, but there's no reason to not have more. If you guys have questions, I'm happy to do them. Thursday, possible review if necessary. And then Monday and Tuesday are going to be your final exam. Let me look exactly how many questions that I've written for that, so we can get as much information as possible. And the time limit as well. I'll give you all that information. It is, of course, cumulative. Alrighty. I think it's... yeah. Okay. So it is 50 questions. And 150 minutes. So you have 3 minutes per question, essentially. That's 2.5 hours. So your brains can be destroyed slowly over that period of time. You can take it any day or either day you want. So it'll open and it closes Tuesday. So you'll have a 48-hour window to take it, but you do have to take it in one sitting because it is a timed exam. So you'll want to set aside a 2.5-hour block for that, where you can have quiet and, a relatively peaceful environment to take it. So you can minimize distractions, that sort of thing. Of course, this will be open whatever because I can't stop you, but again, please don't use each other. And yes, so how this will work also is I do end up duplicating your final exam score, so you will see it twice on Canvas. But the duplication will be treated as a regular exam. And what I'll tell you Canvas to do is it will drop your lowest exam. So you have 4 exam scores right now. You will get a 5th one, which will be a duplicate of your final exam, and it will drop whichever one of those 5 is lowest. So if it helps you, your final exam score will replace one of your previous exams. If your final exam score is the lowest, then that won't help you. So yeah, of course it is cumulative, a little bit more focus on acid base. So just keep that in mind. All right. If it's the lowest, then you're out of luck. Then none of your exams will be dropped. Then yeah, it'll drop the duplicate basically. Yeah. So it'll just choose the lowest one and it'll drop it. So yeah. But then obviously you don't get any benefit that way, right? Oh, and I guess I should give you guys some extra credit, huh? Probably would like that. What I'm going to do is I'm going to just put up a survey for how you felt about the class and all that sort of thing. And so, free extra credit. You still have to take the final exam because it's 20% of your grade, right? So, let's look at that more closely. So, you have exam 1, 2, 3, 4 that you've taken. Those together are 30% of your grade. And then you've got your final, which is 20%. Creature, relax. What are you doing back there? So what the final will do is your final will also go into the 30% pool. And so it'll choose one of those 5 now to drop. Of these 5. So that's what that means. So you still need the, I mean, if you are happy with a C and you just don't want to take the final, that is fine. You can do that. I don't recommend it. You might as well try, right? Yeah. So yeah. What was I gonna say? Oh yes, extra credit. Yeah, I figured. I'll post that up there. It's just a survey of what you felt about the class, about the teaching style, and blah, 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 all that fun stuff. You can be totally honest. It's there to make me do better. I'm not going to look at them until after the grades are posted, except for the part that I'm going to ask what your name is. So I can give you credit for that. It'll just be a 1% boost to your grade if you do it or not. So easy stuff. It's not a long survey. So, all right, cool. Well, with that, we'll finish for today. We will resume on Wednesday with our review session, which may or may not go into Thursday. You guys can still keep posting questions, up until Wednesday night if you like. But the sooner you get them in, the better, I would say, because that means the sooner I can answer them. So, and if there are questions, of course, still after that, we have our Discord. Throw them there. We'll go over them. But yeah, so we're done with all the new stuff. So, all right. Alrighty then. In that case, enjoy the rest of your day. Enjoy tomorrow, and I'll see you on Wednesday. Take care.